Hello everyone, I'm Paul and today we're solving problem 3021, Alice and Bob playing flower game. This is medium and the key to solve this is observation. So next I will show you my intuition, approach and efficient solution. This is a nice description, you can read this if you want, but basically we are playing a game here. There is a circular field with two people in it, Alice and Bob. And in between Alice and Bob we have flowers. We have from 1 to n flowers in clockwise direction and from 1 to m flowers in anti-clockwise direction. So let's say we have one flower here and another one here. And the game goes as follows. Alice takes the first turn and she has to grab one flower. So let's say she decides to grab this one. Next, Bob has to grab another flower. So the only available flower is this one and he grabs this. Now, at the end of the turn, if there are no flowers left, the current player wins. So in this case, Bob wins. Now we are given these values n and m, and our job is to return the number of possible pairs in which Alice wins. So for example, for the pair 1, 1, Bob wins. And what this means is we have one flower here and another one here. Let's say n is 3 and m is 2. And we will try a few simulations here. We know that for the pair 1 and 1, Bob wins. Given that m is 2, we can use up to 2 flowers here. So let's say that now we have 2 flowers on this side and 1 flower here. Alice always starts. So let's say she decides to grab this flower, then Bob grabs this one, and then Alice grabs this one. And given that this is the end of Alice's turn, Alice wins. So when we have this scenario, meaning 2, 1, Alice wins. And if we have this scenario, for example, Alice also wins because let's say Alice grabs this one, then Bob grabs this, and finally Alice grabs this one. And given that this is the end of Alice's turn, Alice wins. So for 1, 2, the winner is also Alice. Finally, let's say we have this. Alice always takes the first turn, so she grabs this one, then Bob grabs this, then Alice grabs this, and finally Bob grabs this one. And given that the end of the last turn is Bob's turn, Bob wins. So when we have 2, 2, the winner is Bob. And here's all the information we need. There's a big observation to make here. Whenever we have an even number of flowers, Bob wins. For example, here we have 2 and Bob wins. Here we have 4 and Bob wins. And whenever we have an odd number of flowers, Alice wins. So here we have 2 and 1, Alice wins. Here we have 1 and 2, Alice wins. And you can try as many scenarios as you want, but whenever we have an even amount of flowers, Bob wins. And whenever we have an odd amount of flowers, Alice wins. So in case you didn't notice, this is basically a math problem. We just need to find every combination of numbers from 1 to n, which is 3 in this case, and from 1 to m, which is 2, and the sum for each of these combinations has to be an odd number. So we just need to return the number of these combinations. Let's see how can we use this information. We know that n is 3 and m is 2. So the possible amounts of flowers in clockwise direction are 1, 2, and 3. And the possible amounts of flowers in anti-clockwise direction are 1 and 2. And we need to return the number of pairs in which Alice wins, meaning the number of pairs that have an odd sum. If we sum an even number and an odd number, the result is odd. If we sum an odd and an even number, the result is also odd. So we can use these scenarios. Now, if we sum even plus even, the result is even. And if we sum add plus add, the result is also even. So we can forget about these two scenarios. We only need this. And now the question is, how many even and odd numbers do we have in this amount? And how many even and odd numbers do we have in this amount? Let's see, this is odd, this is even, this is odd. So for n, we have 2 odds and 1 even. And for m, we have 1 odd and 1 even. So this is 1 and 1. Now remember, this is our winner formula. We need an odd sum because Alice needs to win. So we can take an even plus an odd. Let's say we take this and this. 2 plus 1 is 3. This is odd, so here Alice wins. Now let's try this. We can take 1 odd, so let's say we take this, and 1 even, let's say we take this. 1 plus 2 is also 3, so the pair 1, 2 is also successful. Here Alice wins. And finally, let's say we take this odd and this even. 3 plus 2 is 5, which is odd, so here Alice also wins. So the pair 3, 2 is also successful. And given that we have only 3 successful scenarios, we just return 3. Now the question is, how can we get this number with this information? Well, we can just take the evens for n times the odds for m. And this is how we get the pair 2, 1, which is this one. So let's say the result is initially 0, and we add this, so the result is now 1. Similarly, we can take the odd amounts for n times the even amounts for m, and 2 times 1 is 2, so we add 2 to the result, and this is 3. And this represents this and these pairs, 1 and 2 and 3 and 2. So we are given these two values and we need to return the amount of scenarios in which Alice wins, meaning we have an odd sum of flowers. So we take the sum of odd amounts in n, which is 2 here, and the sum for even amounts in n, which is 1, and we do the same for m. Here the result is 1 and 1, and then for the result we just do this times this plus this times this, and this is how we get 3 in this case. So as you can see, this is a math problem that's all about observation, and time and space complexity here is big O of 1. So now let's go with the code. Let's start small here. Let's say we are trying to get the count for even amounts in n. We will call this en. This is n divided by 2. Similarly, if we want to get the count for odd amounts in n, this is n divided by 2, but if n is an odd number, if this modulo 2 is different from 0, we need to add 1 here. So in this case, on plus equal 1. And we need to do exactly the same for m. So em is m divided by 2, om is m divided by 2, and if m modulo 2 is different from 0, om plus equal 1. And finally, we can return on times em plus en times om. So now let's submit this and see if it works. As you can see, this works and it's very efficient. And we can reduce this to simple code. We can just say return, and here we have two parts. First, m divided by 2. This is even amounts for m times
add amounts for n, meaning n divided by 2 plus n modulo 2. And here we say we can just copy this and say plus this. And here we do the opposite, meaning n divided by 2 times m. And here we have another m. Now let's submit this just to show you this also works. And as you can see, this also works and it's basically the same. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.